Number 7, row 3. 2 cubed times 2 to the 5th. I can approach this in one of two ways. I can use my rules for multiplying exponents with the same base. When I multiply exponents with the same base, what I do is I simply add their powers. So this would become 2 to the 3 plus 5 power, which is equivalent to 2 to the 8th power. Why this works? Well, what I'm doing is I'm taking 2 times itself 3 times, so 2 times 2 times 2, and then multiplying that by 2 times itself 5 times. So I've got 1, 2, 3, 4, 5 more 2's. Altogether, that's 1, 2, 3, 4, 5, 6, 7, 8 2's, thus 2 to the 8th power. 6 to the 0 power, anything raised to the 0 power is 1. We did a great deal of talking about this in class, so I'm not going to offer an explanation right now as to why 6 to the 0 power is 1, but if you'd like help on this topic, please feel free to let me know. The next problem, 2 to the negative 9th over 3 to the negative 7th. What we need to do in order to make these powers positive is essentially switch their locations. Using the same strategies that we've used in the above two problems, what I need to do is apply the rules of negative powers, which say that if I have a negative exponent and I want to make it positive, I just switch the location of where the exponent is, meaning if it's in the numerator, I put it in the denominator, and if it's in the denominator, I put it in the numerator. So 2 to the negative 9th, that would go down in the denominator, but I would make it 2 to the positive 9th. 3 to the negative 7th, it starts in the denominator. To make it a positive 7, what I need to do is move it to the numerator and just make it positive. So I just switch the location of those two exponents and also flip their signs.